Every time you open maps on your phone, you are relying on simultaneous equations to calculate how far away your destination is. Not just that, they can also help you calculate income over time, mileage, or predict company profit. They are even used in air traffic control. They are everywhere. See these 4 pairs on your screen? You too must have seen such sets of equations involving variables and numbers where the motive is to find the unknowns. Finding these unknown values is referred to as solving the equation. But how do we generally solve a system of linear equations? The techniques we have used so far are elimination and substitution. What if I tell you that we can use matrices to solve them? You heard me right. A major application of matrices is solving a system of equations, also known as simultaneous linear equations. Generally, a system of equations looks like this. There is an entire chapter in your course dedicated to linear equations, where we will be covering all the related details. But still, we need some basic information to get going with this topic. First things first, these x and y are known as the variables. Next, these a, b, c and d that are attached to the variables are called the coefficients. M and n are called constants due to the fact that they are on their own without any variable. Excluding the variables x and y, all the other elements a, b, c, d, m and n are real numbers. Unsure about what a real number means? Don't worry, we are going to see that in the next chapter. For now, just know this. They are the usual numbers that you are used to seeing every day. Final point. Solving an equation simply means to find the value of the unknowns, which are x and y in our case. I hope you have understood all the points. For now, this information on simultaneous linear equations is enough to deal with this part of chapter 1. Now, let's also talk a little about the 2 methods we will be using to solve them. The first method is called the matrix inversion method, while the second one is called the Cramer's rule. Both the methods use matrices to find the unknowns in the given equations. The only difference is the procedure that these methods follow. We will discuss the matrix inversion method and Cramer's rule in general as well as with examples one by one in the upcoming lessons. Is the solution of equations the only application of matrices? Of course not. They are also used in fancy computer science for many things. But that's a bit advanced at this point. You should always start simple. So how about you follow the next lesson, which will walk you through the matrix inversion method. Once you've learned how to solve equations, then we can discuss something more.